Salam and welcome. Today's lesson is about carboxylic acids. So first of all, we're going to start learning how can I produce carboxylic acid and what is the functional group of carboxylic acid. So first of all, you have to put in your mind, if you have alkali group that is bonded to C double bond O, OH, then we can consider this as carboxylic acid. And generally, carboxylic acids are weak acids, okay? These are weak acids. And these weak acids, for sure, they react with bases. Okay, they react with bases, and these bases could be like OH, alkaline solutions, or metal carbonates. So once you have these issues, you can have a reaction in this case. So how can I prepare carboxylic acid? In the previous organic reactions that we covered, we just knew that how can I make carboxylic acid? We can produce it by the oxidation of primary alcohol, okay, or oxidation of aldehydes. Okay, so let's do that in terms of chemical equations and what are the reactions, or let's say reagents in this case. So let's take a primary alcohol, which is the normal one that we used to use, which is CH3, CH2OH. So in this case, this is ethanol and it's primary alcohol. So how can I change it to aldehyde? We can add acidified K2CR2O7, and it's called potassium dichromate, and it works as oxidizing agent. So as a result of the oxidation process, we will have aldehyde, CH3CHO. So we can take the aldehyde in this case by distillation process, but actually our target is carboxylic acid. So we can make further oxidation process, and then we have to add more heat, or let's say apply more heat, and then adding acidified K2CR2O7 again. Once you did this process, you will have carboxylic acid, and this group will change to C double bond OH, or CH3 COOH. This is called ethanoic acid. If you want to name the carboxylic acids, first of all, you have to count the number of carbons. Here we have 2, then it's ethane. Okay, we drop the E, and then we put OIC, and then add word acid. So this is ethanoic acid. Okay, perfect. So this is the first process. What we conclude here, we can change the primary alcohol to carboxylic acid, and we can oxidize the aldehydes to carboxylic acids. But put in your mind, the potassium dichromate is not the only reagent that you can prepare it. We have another one, which is acidified KMnO4 and presence of refluxing. So once you apply these conditions on alcohol or on aldehyde, you will have carboxylic acid. Perfect. Okay, I just want to remind you with something that we talked in previous classes, which was the oxidation of alkenes. So once you have something like this, for example, like CH2, then you have to add oxidation, or let's say oxidizing agent. You could have carboxylic acid in this case, because this action here will change to OH later on, and it becomes like this C double bond O, OH, and we have to put these issues together, complete it. All right, so this is the first reaction. Another reaction that you can make carboxylic acid is the hydrolysis. This is reaction number 2, which is hydrolysis of nitriles. How to do that? Okay, in the previous video, we talked hydroxynitriles, okay, and we just put in our mind, for example, like you have CH3, CH2, CN. In this case, you have a compound which is a propane nitrile. Once you make hydrolysis process, which could be done by alkaline solution and then followed by acid, or by dilute acid, it could be dilute hydrochloric acid, you can change it to carboxylic acid. So once you have this example for like this, you have propane nitrile. If you add dilute HCl, you will change the CN group to C double bond OH, and you will put the other components as they are. You have CH2 in here and CH2 in here. So this is a propanoic acid. This is a propanoic acid. Suppose that you have this compound, C, and here we have OH, and we have CN, and here we have C2CH3. And we just apply dilute hydrochloric acid, let's say HCl, dilute. What will happen here? First of all, you have a nitrile group in this case, and you have dilute acid, then the process is hydrolysis. What will be the target functional group in this case? The HCl will hydrolyze the CN group only. So your compound will be, you will change the CN to C double bond O, okay, OH in here, and then you will put all of these components as they are, OH, and here we have CH2, and here we have CH3. Okay, and now you notice that this is a compound that contains two functional groups. You have a functional group of carboxylic acid and you have a functional group of alcohol. So how to name such a compound? Okay, first of all, this is hydroxycarboxylic acid. Okay. The first step in this case, you have to start counting the number of carbon atoms and finding the longest chain. We start counting from carboxylic acid. So here we have 1, and here we have 2, and here we have 3, and here we have 4. Then we have 4 atoms or 4 carbons. Then this is a butane. Okay, butane. All right. And we have carboxylic acid, and then it will become butanoic acid. Okay, so this is the first thing here. And you just notice that once you have OH group in the presence of another functional group, then we call it hydroxy. Okay, and we just noticed that the hydroxy group is in the second carbon in here, so we have to put 2 hydroxy. Then it will be 2 hydroxy, okay, butanoic acid. So this is your compound. This is 2-hydroxybutanoic acid. And by the way, it behaves the same as carboxylic acids. It reacts with bases like CO3, carbonates, and it reacts with OH negative, which is alkaline solution. And it also reacts with metals. Yeah, it reacts with metals. So we can prepare carboxylic acids in either oxidation of primary alcohol or aldehyde. And we can make hydrolysis for nitriles using dilute acids or alkaline solutions that are followed by acidification. And now let's go to the hydrolysis of esters. If we make hydrolysis for esters, we could have carboxylic acid. So how can I make hydrolysis for ester? Okay, so let's take a normal ester, or let's say example, CH3, CH2, C double bond, O, C2H5. So in this case, we have ester, and we just want to recall the esters. Esters are a combination of alcohols and carboxylic acids. So the first part in here of ester, it comes from carboxylic acid, okay? And the second part that comes after oxygen in here, it comes from alcohol. So if you want to call this compound, we take the first one, ethyl, and we just take this one here, which is 1, 2, 3, made of 3 carbons, and call it propanoate. So if you want to name an ester, you have to take the part number 1, which comes from alcohol, and we put it in form of alkyl like ethyl, hexyl, propyl, butyl. And then we just go back again to the first part, which is the source of carboxylic acid, and it's called propanoate. We add OATE at the end of the name. So this is called ethyl propanoate. Okay, so if I want to make hydrolysis for this one here, how can I deal with such equation? I just want to write it here. CH3, CH2, C double bond, O, CH2, CH3. This is ethyl propanoate. We can make hydrolysis by acid, and then it's followed by acidification, but we have to apply heat in this case. Okay, so if I want to make a hydrolysis for this process, I can add acid. Suppose that I'm going to use dilute HCl and heat So what will be the product? First of all, you will change this part into carboxylic acid, and it appears as propanoic acid, CH3, CH2, C double bond, OH. So this is a propanoic acid. And this part will change to its original part, which is alcohol. And we have CH3, CH2, OH. So these are the components of your compound. So we have another thing. If we just make hydrolysis using OH negative, how can I deal with such equation? First of all, I just want to take the examples that we talked above: CH2, CH2, C double bond, O, CH2, CH3. And if I add OH negative in presence of heat, what will be the product in here? Actually, you will break down the compound and we will get the same things, but we have a little bit difference in here. Difference, the part of alcohol remains as it is. There's no change. CH3, CH2, OH. No change on this part. But this part will change to what? It will change to carboxylate CH3, CH2, C double bond, O and A. Okay, so in this case, this compound, you can make acidification by adding more acid, and then you can change it to acid as well. CH3, CH2, C double bond, OH. Okay, so this is the compound that you can use in here, and this is carboxylic acid, and this is the ethanol or the alcohol.